problem is to find the difference quotient for this function. And I've written the difference quotient right over here. So the key to doing difference quotient problems is to look at the difference quotient in three separate pieces. F of x minus h, f of x plus h minus f of x all over h. What that means is something we can discuss in class, and we'll go over it again. But technically speaking, this is how we got to approach this problem. So I have, this is my function, f of x. And if I ask anybody in the class, what is f of 3, they would say 2 times 3 squared minus 3 times 3 plus 8. What we're doing when we're finding f of 3 is we're substituting 3 in for every instance of x in the function. We are evaluating the function at the point 3. Well, I don't want f of 3. I want f of x plus h. But we can follow the same process. I would go 2 times, instead of 3, x plus h squared minus 3 times x plus h plus 8. So that is what f of x plus h is all about. Well, I'm looking at my difference quotient, which I would encourage you to kind of maybe write down on a piece of paper on the side so that you can kind of follow along. That's our difference quotient. And what I want is this. I want f of x plus h, so I'm going to write that again. I want f of x plus h, which I know is equal to this. So 2 times x plus h squared minus 3 times x plus h plus 8 minus f of x. Well, f of x is right here. It's my original function. So f of x is, put it in parentheses so you don't lose your negative sign, 2x squared minus 3x plus 8. So that, right here, this is f of x plus h, and this is f of x. And we've subtracted f of x from f of x plus h. I'm going to put that all over h. Once you set it up, then the rest of it is algebra. So let's start with let's go left to right. I have 2 times x plus h squared. Well, x plus h squared is the same thing as x plus h times x plus h. It is not x squared plus h squared. X plus h squared, the exponent does not distribute to the terms inside the parentheses. It is not that. We have to either FOIL it or know the what it looks like because we memorized it basically, and that is equal to x squared plus xh plus xh plus h squared all times 2 equal to 2x squared plus 4xh plus 2h squared. So let's kind of simplify this a little bit. That's what this piece is equal to. So I'm expanding it out. I have 2x squared plus 4xh plus 2h squared. Now I'm going to distribute my 3 up here to these two terms, because that is multiplication. It's a negative 3, so I have negative minus 3x minus 3h. I can't forget my plus 8. That's still part of the the thing I'm trying to simplify. Now I'm going to go minus, I got to make sure I distribute my negative sign to all three terms here. So I have minus 2x squared plus 3x minus 8, and that is all over h. It looks nasty, but it's really not, because I have a 2x squared and a negative 2x squared. And I have a, what else do I have here? I have a positive negative 3x and a positive 3x. And I have a positive 8 and a negative 8. So all I'm really left with is 4xh plus 2h squared minus 3h all over h. And I'm not done, because I have a common term in my denominator. My denominator has an h, and every single one of the terms of my trinomial also has an h. So I know that I can then simplify this a little bit further. So I would do that by going, the numerator is called h times 4x plus 2h minus 3 all over h. I have an h that I can cancel out now because I have a product. And my answer to this problem is 4x plus 2h minus 3. And no, it doesn't make any difference. I could have written it 2h plus 4x minus 3, or I could have written it minus 3 plus 2h plus 4x. They're all the same because addition is commutative. So that's how you solve this difference quotient problem.